Today's lesson is on section 5.3, write linear equations in point-slope form. In this chapter, there's going to be three different forms that we're going to use to write different linear equations. And again, as I've said in the past, too, no equation is definitely necessarily better than another one. They all will be linear equations. If I graph every one of them, it will form a straight line. But sometimes in certain problems, one form might work a little better than the other, be easier to make. Point slope form, as we're going to find, is maybe not the most popular one we use of the three forms, but it is one that is very easy to make, and we will see occasionally. You'll see it on the MCA. You'll see equations like this when you go into high school math, ones that are formed very similarly. So it's a good one to work with. As I've got up here, and if you're taking notes along with me, here's what I'd like you to write down today. I've got all this in red. Again, if you're taking notes, the text that's in red is what I'd like you to put into your notes. It says there's three forms of linear equation, like I was talking about. And you may have seen this list before too, and that's all right. Number one, again, slope-intercept form. Again, that's maybe our star one. Okay, that's the one that we use all the time in linear algebra. The one we use even most often in this chapter, previous chapters, and as we go on, it's just the one that's the easiest. It ends up being to work with and to graph with, and a lot of problems form with problems in slope-intercept form. Point-slope form is the one we're going to work on today. So point-slope form, and again, here's the form for that equation. And I'll explain a little more here as we go forward too. And just also just noting, since we're here, standard form is the third equation that I've got down here, and that one we have also worked with a little bit already this year. But point slope form is the one we're going to talk about today. Here is point slope form if we have not seen it already. And as you can see, we still have our variables x and y in here. Okay, here's y and here's x. When I make some kind of equation, those will still be visual there. When I'm making the equation, those variables will still be in those spots. But notice that I do have another x and y in here as well. I have y, and they call that y sub 1 and x sub 1. What those are there for is in point slope form, there's going to be certain numbers that we're going to plug in, just like in slope intercept form, just like in standard form. And in this particular case, this is where we're going to plug in some numbers to make our equation. And hopefully that variable m is another number we kind of recognize. M is usually our slope of our line. That also shows up in point slope form. Okay. As I go through the next couple pages, I'll talk about making point slope form, but just one thing to note, I don't want students to be too confused by the name of point slope form. Going back to slope intercept form for a second. As I say many times in class, slope intercept form, I always ask them what are the two key pieces of information, and what are the two things we need to make an equation in slope intercept form? Well, what do you know? We need the slope and the y-intercept. We always start off with m equals and b equals. M stands for slope, B stands for y-intercept. So what do you know? In slope-intercept form, we need the slope of the line and the y-intercept of the line. So just realize the key pieces we need are right in the name there. So, as I'll ask students in class, in point-slope form, what do we think the two key pieces of information we need are? Well, we need one point, one ordered pair that the line goes through, and again, we need the slope of the line. So when we're putting these equations together, those are the two things we will look for. If I can find one point on this line and then the slope of the line, I can make an equation in point-slope form. So jumping ahead here to what some problems might look like in our homework and what we can expect maybe to how to make an equation in point-slope form. I've got a typical problem here you might see, and I've also got point-slope form right up here up to the right. So again, if you didn't get a chance to copy it down already, there's what it looks like. As always with any equation, I won't ask you to memorize it, but it should be something that hopefully you get familiar with. And anytime we do some kind of problem, they'll maybe put it at the top, or any kind of assignment, put it at the top of your assignment when you're going to use point-slope form. When you're taking it on the MCA, you will have this on the formula sheet as well, point-slope form right there. So again, nothing I ask you to memorize, but do be familiar with it, and if you memorize it, even better. Okay. So going in the problem here. Looks like problems we've seen a lot in this chapter. It says write an equation. This could be an example problem from your homework. Write an equation in point-slope form. So in this form, the one we're working with today, that has a slope of 4 and passes through the point 8, 1. So when we're doing problems with slope-intercept form, I usually have people start off, what's your slope and what's your y-intercept? And do we have these pieces of information? Well, for point slope form, I'm just going to change it just a little bit. We still want the slope of the line, but now we just need one point, any point that this particular line goes through. And this problem, they're being pretty nice. They've given us the slope, which is 4, and they've given us a point that it goes through, 8, 1. So I've already got the two pieces of information I need for point slope form. I have a point, check, and I have a slope, check. So I've got the two things I need. I can go right to my equation now. As I look at point slope form, okay, looking at what it looks like here, m still goes in kind of a usual spot. We see it right after an equal sign, and we still have y on the left side, but now it says y minus y sub 1. This is going to be the y coordinate. So in this case, using a different color here, this is going to be the y coordinate in my ordered pair. The second number is always the y coordinate, so that's where the 1 is going to go in. It says over here x sub 1, okay? That's, again, we have x and then minus x sub 1. Well, that's going to be where the x coordinate goes in. So in this case, that's going to be 8. So I've got the two numbers I need. I've got the slope that I need. I'm just going to put this equation together. Here's what it'll look like. And if you're, again, taking notes along with me, you try to put these together before I even get to them. So it'll look like y minus, and then my y coordinate is 1. So y minus 1 equals, well, my slope is 4. And in parentheses, I'm going to have x minus 8. And again, we can go into more about like why is the equation formed this way, and what does the parentheses do, and subtracting it from y from 1, what does that do? But as you go through high school, you will see more equations like this, and it'll make more sense as you work with them. But this is kind of a nice little introduction to that. Again, it looks a little different because we do have, usually when we're used to slope-intercept form, I just have y by itself, but now on the left side I do have another number with it, y minus 1. Okay. Also keep in mind, and we'll talk about this in the very next problem, okay, but that is my equation there in point slope form. Notice how my y coordinate was 1, but in the equation it says y minus 1. Keep that in mind. I'll talk about that as we go through some more problems. And same thing with the 8. The x coordinate was 8. But what does it say over here? It says x minus 8. Okay, that is just the form of the equation. Those should be subtraction signs there, so that is going to affect my problem when I plug in different numbers. Let's go to another one here. So make an equation in point slope form of a line that has a slope of negative 19 and goes to the point 20, 100. So again, for point slope form, I'm going to need a point or some kind of ordered pair, and I'm going to need a slope. So the slope of the line is negative 19. The ordered pair is, or point that it goes through is 20, 100. So I'm just going to put those numbers in. Again, you can do it ahead of me, but or pause the video and see if you can get these examples before me. But this one should be y minus 100, because that's the y coordinate, equals, the slope is negative 19, x minus 20. Okay, so far so good. There's us putting an equation in point slope form. Not too bad at this point. Okay, looking at this next one. Same thing. It says it has a slope of 1/2. So we have a slope of 1/2, and we go through the point negative 7, 4. Okay, so again, picking out my ordered pair, negative 7, 4, and my slope is 1/2. Okay, if I start making this equation in point slope form, just like the ones above, I'm going to say y minus, well, my y coordinate is 4, and then equals, my slope is 1/2, and in my parentheses now, before I've been doing x minus whatever the coordinate is, right? Well, as I go through these problems in class, somebody will usually notice, and I'll have people doing these problems ahead of me, but if I put negative 7 in here, what happens? Well, I have x minus negative 7, and we have dealt with this many times this year. What happens when we have minus and negative? I usually say chop, chop, and we're going to turn it to addition sign. That is what happens in point slope form. If there's one little tricky thing to keep an eye on, is that when you put in a negative coordinate, what does it actually look like in the equation? It'll look like plus that number. Again, go back to that first one that I talked about. Okay, when we put in y minus 1, what's actually the coordinate? It's still positive 1. Just looks kind of interesting that way, but that is the way this particular formula works. Same thing with the x minus 8. Well, the coordinate was positive 8, but the formula makes it look like it has a subtraction sign in front of it, so it makes it look negative, but really it's not. That's just what this formula calls for. Okay, so going through one more example on this page, and I'll bring point slope form down here in case you still need it. Let me drag that with me. So if I want to put this new equation in point slope form, it has a slope of negative 7 over 2, and an ordered pair of -9, -2. When I start plugging these numbers in, so y minus -2 I could think, because that's my y coordinate. But really, what's going to happen is I would chop that, so I can just write, when I put in a negative coordinate, it's going to be like y plus 2 is what I'm going to end up with there. The slope is -7/2. And then in parentheses, again, I'm going to have to plug in -9. So really, I'm just going to jump ahead and say x plus 9. So that's what it's going to look like in point slope form. Just one small thing to keep an eye on. But as long as we know that trick, the form itself, not too bad to work with. Last couple examples here I'll go through in this lesson. I'll just teach us, well, how do we graph then using point slope form? And it's very similar to what we were doing, just kind of going the other direction. Now, if I've got an equation here in point slope form, well, that means I can pick out one point that the line goes through, and I can pick out the slope. The slope is still kind of in a common spot, like we said there. The slope is going to be 3. And the ordered pair, though, now, again, looking at point slope form like we talked about, the ordered pair, for this point slope form, it should show up as subtraction signs in front of it if those are actually positive coordinates, because again, that's what the formula looks like. The x coordinate's going to be over here near the x, so that's kind of a hint for you. The y coordinate's going to be over here near the y. So what is this point really? This point is actually 4, 2. That's what this formula is telling me. This equation goes through the point 4, 2, positive 4 and positive 2. Because again, the formula is supposed to be subtraction. So 4, 2, and has a slope of 3. Well, we've actually done problems just like this. If you know that the line goes through a point 4, 2, well, 1, 2, 3, or 4. So over 4 up 2, there's the point 4, 2, and it has a slope of 3. Well, now I'm just going to use that slope, up 3 over 1, up 3 over 1, or if I want to find what the y-intercept is for like a slope-intercept form, or just to make my line more accurate anyway, I can go down 3 and left 1 as well. And I can graph my line using that information. There's what my equation would be. Going on to the next one here, I'll just graph them all on this particular grid. Again, my ordered pair and my slope is what I need for point slope form. The slope looks to be 2. The ordered pair, so it's x minus 1, so this should be 1. And x plus 5, again, since this is plus, think about the previous examples we did. That means that actually there was a chop to make that plus, because the formula says that it's supposed to be subtraction. So really this is going to be -5 for my coordinate. So 1, -5 is where this line goes through, 1, and then 1, 2, 3, 4, -5, and has a slope of 2, so up 2 over 1, up 2 over 1 is actually going to cross the other line I had. I can go down 2 and left 1, make it nice and accurate. There's my red line. This last one here I'll do. Y minus 3 equals 1/2 x plus 6 in parentheses. So again, this equation's in point slope form. So here's what it'll look like on the homework. You do the same thing. I'll pick out the slope. I'll pick out the point. Again, this is x plus 6. So in this particular formula, that actually means that the coordinate is -6 for x and positive 3 for y. So 1, 2, 3, 4, 5, 6. 1, 2, 3. There's the point -6, 3. And a slope of 1/2 means up 1 over 2, up 1 over 2. And I can make a bunch of points. And we'll talk soon about also making these in slope-intercept form if I needed to. But that's what my graph would look like. So there's graphing with point-slope form. Similar to other ones we've done too. I just pick out the key information, and I'm ready to make my graph.